Hello friends, welcome back to CAD Practice. Today we are going to construct a 3D model of heat exchanger in Autodesk Inventor software. We will make the heat changer in assembly. For that we will make its several child parts. So let's get started with today's modeling. Take take a sheet metal part in millimeter. We will first start with this inner profile or these inner plates. So for that, go to 2D sketch, take the XY plane, it will be your front plane, go to rectangle command, go for the 2 point center rectangle, select the center point, take a width of 44 mm and a height of 210 mm. Okay, now finish sketch, go to face tab, okay, and apply. So the by default thickness for this will be 0.5 mm. You can check the thickness of the sheet from here. Go to sheet metal defaults. It will show you the thickness of 0.5 mm. Okay. Now select this face. Go to create sketch. Now we will make a new sketch. So take the circle command. Make a circle of 6.2 dia and here a circle of 10 mm and a circle of 11 mm. Similarly here a circle of 10 and a circle of 11 mm. Okay, now go to dimensions, give a dimension from here, it will be 10 and from side this will be 11 mm. Now go for the constraints. We will give the vertical constraint first. Select this center point and select this center point. It will be vertically aligned with respect to this circle. Now go to horizontal constraint. Select this center point and this. Now this circle will be horizontally aligned with this circle. So it will just move here. It will not move up and down. Similarly, this will move up and down and not move by side. Okay. Now go for a line command. Select this center and this center and okay. First give a dimension of this circle as 11 mm. Okay. Now select this line, right click, go for construction geometry. This is just a construction profile or a reference profile which we have made. Go to dimensions, select this line and go right click, go to aligned and give it a dimension of 25.303. Okay. Now go to rectangular pattern, select all these circles. Now select this as a directional vector. So it will ask you in which direction you want to pattern this. So it's going upward. Select this to flip the direction to downwards and we will take a count of 8 and the center to center distance as 25 mm and okay. Now we need to make the same circle over here. So make a circle of 6.2. Now we will not give any dimension. We will go for horizontal constraint. Select this center points and vertical constraint. Select this center point and this center point. It's fully defined. Okay. Now finish sketch. Now go to cut command. Select this profile and this profile. We will select only the inner profiles, not this thickness we have left. Okay. we are cutting the 10 dia circle, and okay. Now we'll right click and switch on the visibility. Now we have cut this profile. Select this as well. Select this profile also. Okay, no, don't select this. We'll do it later. So go to rectangular pattern. Select this feature we want to pattern. The direction will be this vector, a count of 8, and the center to center distance of 25 mm. Okay, and apply. As you can see, uh, the pattern will be applied for these profiles. Now we want to extrude this outer edges. So go to extrude, select this thickness, similarly for this, and give a dimension of 4.5. Okay. Okay. Now we'll go to rectangular pattern once again. Select this extrude feature. To ask you the feature, so go for this extrude. Go to direction. Give a direction here. Flip it and give a count of 8, and the distance between each will be 25. It is going upwards, so flip the direction and okay. There is some error. So go to rectangular patterns again. Select this. Give this a profile. Flip. It's not flipping. There is some error. I hope so. Delete this rectangular pattern. Now take the rectangular pattern of this cut and this solid extrude and give this. Okay, now it's been selected. Now take a count of 8 and distance between each will be 25 mm and okay. Now we are done with only single command, the cut and the extrude. Okay. Now we are left with these profiles when to be cut, this upper profile and this lower profile. For that, go to cut, select both these profiles, select this profile and select this profile and okay. So whole profiles are being cut and extruded. So go to the sketch, right click and switch off the visibility. Okay, now this has been made. Now save it. Okay, we will save it here. Make a new folder with the name of heat exchanger, and yeah, I will take it one. Okay, now open this and we'll save it as center support plate and save. Now with the help of this center support plate, we are going to make this side support plates. The difference between them is this outer flange and this whole profile. So first switch off this assembly. Now go to save as. Just change its name to side support plate and save. Now its name is being changed to side support plate. Remove this rectangular pattern. Okay, just wait. Remove this extrude. Only the rectangular pattern for cut will remain. And switch. Now right click and switch off the visibility. Okay, now this profile is being removed. Now we need to make a flange, so go to flange, select this edge and give a dimension of 20.5 mm. Okay, now select this face, go to create sketch, make a circle of dia 7 and make a line over here at center. Okay, and make it as construction geometry, or you can center line. Okay, now give this dimension. From top it will be 10 mm, from side it will be 8 mm, and finish. Okay, the purpose of line was, go to mirror, select this profile, select this center line, and this will mirror it on the other side. Now finish sketch. Now go to cut and select this circle, and okay. Now the side support plate is also been made, and save it. Okay, the sheet metal portion is done. This plate and this plate are same, you can just mirror them, and this profile is done. Now we have to make this support rod which passes through all the plates. So to make this support rod, close this, take a standard part in millimeter, take a 2D sketch on XY plane. The support rod will be of dia 6, so take a circle of dia 6, extrude it. We will extrude it symmetric at a distance of 282.5. Okay, now select this edge and give a chamfer of 0.5. Similarly this edge, a chamfer of 0.5. As you can see, we can give a nice appearance over this as well. So just save this part as support rod. The folder will be same for all the parts. Now we will make the pipeline. So we'll start with this pipeline which is going through from here to here. So we'll take a standard part in millimeter once again, take 2D sketch on XY plane, take the circle command and make a circle of dia 10 mm. Go to extrude. We will extrude it symmetric or at 290 distance. Okay, so the pipe which will pass through the heat exchanger will always be hollow from inside. So take the shell command, take a shell of 0.5. Shell is basically provide the thickness, so it will be a thickness of 0.5 mm thick pipe which we will put there, and okay. So now we will change its appearance to copper polished. Select the copper polished and okay. It will be the main pipe. Okay, now we will make the joining pipe for these main pipes. So for that, take a standard part in millimeter, take a 2D sketch on XY plane and make a circle of dia 25.303 and make a center line passing from its center. Okay, as it's been dragging upwards, so go to constraint, coincident constraint, select this and select the center point. Now it's fully defined. Select this line, right click and go to construction, go to trim command and trim the bottom profile and OK. Now take the line command, make a line of 2 mm with 90 degree, make a line of 2 mm. Similarly, make a line over here, make a line of 2 mm over here also, and finish sketch. Now go to plane, select this point and select this line. It will construct a plane on this point. Select the plane, go to create sketch, make a circle of dia 10 mm. As you can see, this circle is not constrained, it's moving. So go to project geometry, select this endpoint where the line is been ending, and drag this center point and place it over here. Now it's fully constrained. Okay, now go to sweep command. This profile which we want to sweep is automatically selected. Now it's asking you for the path, so the path will be this profile and OK. Now we'll want this as hollow, so go to shell command and a hollow of 0.5, select this face and this face and OK. Select this, right click and switch off the visibility. We want its appearance to be like copper, so we'll select copper polished and save it as joint. Okay, now we will make these pipes. For this, take a new standard part in millimeter. For these we will take a 3D sketch. We will make a line over here of 35.3 and here of 87.3, and it will go upward by 27.65. Okay, now just fix this line and fix this point. It's constrained. Now what you have to do is make a line going inside. Select this plane and give a dimension of 37.65. So the profile will look like this. And finish. As you can see, this pipe will go like this. I will show you how it will be placed. This will be like this. Okay, as now the pipe should not have sharp edges, so we'll go back to sketch and give a bend of 12.65. Okay, this end and this end. Okay, and finish sketch. Now as this is complete, this window. Okay, Now make a new plane, select this point and select this. Okay, now make a new sketch on this. Go to project geometry and click on this point. Okay, now make a circle over here of diameter 10. Okay, and go to sweep command, take this as a path and okay. Now take the shell command with 0.5 as thickness, select this endpoint and select the other endpoint as this face. Okay, hide this and give a appearance of copper polished. Okay, and save it as pipe 1. Now save as this pipe as pipe 2. Okay, now pipe 2 just have one change, and that is when we'll place this pipe from bottom, we'll make like this. Okay, now open the 3D sketch. Only this length of 67.65 will increase to 62.65. Okay, rest of the pipe will remain same. Okay, now just save as this pipe and okay. Now we are going to make the assembly part. So go to new, go to standard assembly in millimeter, place the parts, go to place. First we will go to place the side support plate. Okay, for make it constrain, open the origin of this plate and origin of the assembly. Go for visor plane, select visor plane of this, go to constrain and flip and apply. Similarly XZ and XZ plane of both, and XY plane and XY plane of both. Okay, now it will be like this. Okay, select this point. Okay, now we will place joint, no, we will place the support rod. Select this. We want 2 support rods. Change the view to shaded with edges. Now it's more clear. Go to assembly, go for constraint, select this center line and center line of this circle and apply. Select this face and select this face, apply. Similarly center line of this. Okay, not selecting. Select center line of this and center line of this circle, apply. Select this face and this face. As you can see, when we are applying the constraint, it's not moving. So select this side and go to flush, apply. It's like flipping the direction. Okay, now we are going to mirror this. Select this part, go to mirror component, select the mirror plane. For mirror plane, we'll open this support rod profile, open its origin, and the center plane will be XY plane. Okay, and okay. Now it's showing an pin over this arrow, so it's the constraint of grounded. Now we will call the inner profile, so go to place, center support plate. Okay, now go to constraint, select this circular profile, center line. Okay, and this rod, and apply. Similarly this circle and this center line, apply. So it's fully constrained, just moving forward and backward. So select this face and this back face and give a dimension of 5 mm. It will be at a distance of 5 mm from this face, and apply. Okay, now it's fully constrained. Now go to pattern, select this center support plate, go to rectangular pattern. For direction, select this edge and give a count of 55, and distance will be 5 mm. Okay, and okay. So this profile has been made. Okay, this will be like this only. Now for this is done. Now we will call the inner pipe, the main pipe, which will be in between these holes. So we will call 3 of them. Okay, go to constraint, center line, this center line, apply. Similarly this center line and this center line. Okay, now this is left, so this center line and this third circle, and apply. I'll show you on which circles we have applied. So we have applied on these 3. Now select this face and select this end face of the pipe, flush, and give a distance of 7.5. So it will come out by 7.5. Apply. Now select this face and select this face. It will be at a constraint of same plane with respect to this face. Here we don't have to give the 7 point dimension once again. Select this face and select this face. Okay. Now take the pattern, select these 2 pipes, take the rectangular pattern, flip the direction and give a pattern of 7 at a distance of 25. Okay. Now we'll call one more pipe. So select this. Now go to place, go to main pipe, place it. Now go to constraint, select the center line, select any of these internal face, the center line will be shown. So select this, apply, and select this and this face. Go to flush and apply. Okay. Now it's been applied fully. Now what we have to do is, as it's been here and from this side it's been fixed, so remove this fixed constraint, deselect the grounded. Okay, the grounded work was till here. This is an important step, otherwise you will face an error. Now go to place. Now place the joints. Okay, we have placed two joints. For joints we don't have to join this pipe and this last pipe. So go to constraint, select this center, this center, select this, go to opposite alignment and apply. Now it will move it like here, and select this center line and this center line and apply. Now select this face and this face of the joint, apply, go to apply. Okay, now this joint has been placed. Go to pattern, select the rectangular pattern, select this joint, you have to pattern this, select this line, flip the direction to downwards, and at a distance of 25 we need a count of 7, and OK. So it's been joined. Similarly we have placed joint here. So go to constraint, select the center line, select the center line, go to opposite and apply. Go to this circle and this circle, apply. Select this face and select this face of joint and apply. Now here go to pattern, select this joint as the component to pattern, select this line, you can select any of the line, the vertical. Now as it's going upwards, go to flip, give a distance of 25 mm and the count here will be of 8. So it's been joining all the pipes and OK. Now these profiles are being joined. Now we need this inlet and outlet. So go to place, select the pipe 1. OK. So we'll place the pipe 1 with, select this center point and this center line and apply. Drag it outwards. So it's, the constraint is going opposite. So go to edit and flip. This is for opposing or flipping the direction. Okay, now it's perfect. Now go to constraint, select this face and select this face to join them and apply. Now you can just move it downwards. Just give a reference of straightness, as these are copper pipes. These can be moved here and there very easily with the help of hands also. Now place the second pipe over here and OK. Go to constraint, select this center line, select this center line, flip, apply. Now as it's coming outwards, go to constraint, select this face and select this face and apply. Okay, now this whole assembly is being completed. You can just move it like this as per your requirements. So I hope you like the video. If you do that, please do hit like and subscribe the CAD practice channel for more such videos. Thank you.